7.2. Law of signs. This should look a little bit familiar from geometry, possibly. Okay, so we're going to go over what law of signs are. How can we apply it? So we're going to solve a triangle with it, compute the area, and do some application problems with it. Okay, so that's what we're going to do. Now, this does not include the ambiguous case. That's what we're going to do on Monday. Okay, so this is just part one. Part two is going to be what happens if the triangle doesn't quite work out. Like, there could be more than one triangle we're looking at here when it comes to law of signs. So again, I kind of separated that because I think it's just important to get a good foundation of what this is and how to use it. Currently, we can only use trig with right triangles, correct?
Yeah.
All right. Then we did the unit circle. And the unit circle helped us to find angles that were not inside of a triangle, but we were able to figure out what sine of 225 was, and so forth. We're going to merge those together. So now we're going to look at triangles that are not right triangles. Okay? So quick little definition. A triangle that does not contain a right angle is called an oblique triangle. Okay?
Yeah.
An oblique triangle will have either 3 acute angles or 1 obtuse and 2 acute angles. Okay? So they're like the oblique triangles are the muggles of the triangle realm. They're not right. Not that they don't have their place. They do. Now, because we can't use right triangles with it, how do we do this, right? So here's what we're going to do. I'm going to make a triangle that isn't a right triangle, something like this. I'm going to label the angles and then label the sides. Now, if you recall, when we name a triangle and the sides, the capital letters are reserved for the angles, the lowercase letters are reserved for the sides, and the angle is always across from the side that it's named from. Okay, so these are always a pairing, B with B, C with C. Okay, so how can I use sine when I don't have a right angle, right? So here's what we're going to do. I'm going to draw an altitude. Okay, to the very bottom of AC. Okay, so I'm going to call that H. Now, by doing that, I did create some right triangles, didn't I? Because an altitude is perpendicular to its base. Okay, so we got some right triangles here. So let's just say for angle A, okay, using some trig, I have sine of A, of angle A, is equal to H over C, which would be my hypotenuse. Okay? Now, if I were to solve for H, just multiply both sides by C. H is equal to C times sine of A. I'm going to repeat the process for angle C. So here we go. So for angle C, we have sine of C is equal to H, that'd be over A. So I'm looking at the right triangle there, right-hand side. And then again, solve for H. I get H is equal to little a times sine of angle C. Now notice, both of those equations have H in it, right? So because they're both equal to H, I can set them both equal to each other. So therefore, I get C sine of A is equal to A sine of C. And what I'm going to do here, I'm going to put a note. I'm going to divide both sides by AC. And when I do that, I get a really cool relationship that ends up being formed here. Okay? So I'll tell you what, use a different color so we can see it. There we go. And we get the following. So these C's will reduce. I get sine of angle A over the side of A equals, the A's will cancel out. I get sine of C over little c. Now if you look at what we just formed and look at the original shape, bless you. If I get rid of this altitude, which I'm going to just erase real quick, okay? And again, I can't use trig because there's no right angles, but what I proved here is that I don't need the right angles. I don't need the right triangles. Sine of A goes with side A. Sine of C goes with side C. So I can use this relationship to find any missing parts to this triangle that isn't a right triangle. We call that the law of sines, okay? Now, can we do the same thing to figure out like sine of B over little b? Can we get to that conclusion? Absolutely. I would just, instead of drawing my altitude this direction, I would draw my altitude in this direction and repeat the same process, okay? So what I'm going to do, let me put the official, so law of sines is this. Okay? They're all equal to each other, those ratios there. Now, are you going to see that set up like when you actually find measurements, you're going to have three fractions equal to each other? No, you're going to pair them up. So whatever information you have is the set of fractions you're going to be using there. You could, I don't use it this way. Some textbooks do this. Again, nothing wrong with it. But you could have solved this a little differently to where everything gets flipped, like the reciprocal of everything. And again, nothing wrong with that. Both of these formulas here are going to find measurements the same way. Okay, so you might see the formula where they took the reciprocal of everything. And it's still equivalent. There's nothing wrong with that. Okay? So now that we have this, we now have to figure out when are we allowed to use it? Okay? At what points, at what situations does it say, hey, use law of sines? Okay? Because what's going to happen is when we come back from spring break, I'm going to teach you law of cosines. Okay? Which covers the other cases. So let me go ahead and write this down below. For the law of sines to work, we must have the following information. Okay, so we do have a little bit of criteria here. And here's the deal. I mean, do I memorize this all the time? Not necessarily. Because if I look at a problem and I try to use law of sines and I have too many unknowns, that kind of keys off to me that, hey, maybe I don't want to use law of sines. But still, it's good to know some information ahead of time. So when can we use it? We got three situations. Okay? So it's the same triangle. I just drew it 3 times there. This might give you geometry feels, seeing some of these. So looking at it, if you had an angle, a side, and an angle in this formation here, then you can use law of sines to find missing parts. If you had 2 angles and a side that comes afterwards, same thing. And if you have an angle with 2 sides after that, you can still use law of sines to find missing measurements there. Okay, so those are 3 situations that you're allowed to use this with. And again, I mean, if you don't memorize that, that's fine. You'll see when we do an example. When you start using it, you're going to figure out that, hey, I got too many unknowns. So either 1, I got to find a measurement first before I use it, or 2, it's just not possible. Okay. Questions so far? Does that kind of look familiar from geometry? If you took Sosonsky, you probably, I don't know.
Side angle.
I don't know how far in depth you went with it though.
Side angle. I remember those. A lot of proofs.
Yeah, you did Bruce.
A lot of proofs. Sevens.
Unfortunately, in geometry, we're talking about congruency with those, and we're not doing congruency with this. It's just what information do you have? Do you have an angle? Do you have a side? Do you have an angle? So
Oh.
that's what these are going to represent.
Oh, because you use it for similarity too, don't you?
You do. You certainly do.
You can determine two similar triangles by taking a ratio of all their segments.
Yep. Same scale factors.
Right, you're right. That was one of the ones you said.
There's our example. Okay.
Side angle side, not side angle.
If we want, we can put which one of these scenarios it is. In this case, we have an angle, a side, and an angle, so this is a ASA case. But again, not necessarily something you need to write down for solving it. But we are going to find all the angles and all the side lengths. Okay? That's what we're going to do. And looking at it, I can find angle A pretty easily, right? How many degrees in a triangle? 180. So if I add those up, subtract it from 180, I get it, right? Okay? So I just want to write that down as a step. So to find angle A, I'll take 180 minus the 110 and the 32 there. Okay? So we get 38. Okay? So that's done. Nice and easy. Now I gotta find what B is and what C is, right? Those are my next two steps. And it doesn't matter what you try for first. It really doesn't. What I do know is this. Okay? This is 32. I'll put 32 in there now. So sine of A will go with this. So that's two values I know. And if I plug it into the formula, that's good. Then, if I want to find C, I can put sine of 32 over C. That's only one unknown. That I can solve. Okay? So let me go ahead and write that out. So I'm going to put this, sine of A over little a, sine of C over little c. I'm going to plug my values in. Okay? So this is going to be sine of 32, bless you, over 39 equals, oh, 38, my gosh. I even wrote 38 over there. Oops. Sine of 32 over c. Sorry about that. Again, when you set these up, you want to make sure you only have one unknown. If you have more than one unknown, then again, you might have to find something else out, or you just can't use this. We can cross multiply here. So this will be little c times sine of 38 degrees. On the other side, we get 39 times sine of 32 degrees. Got a little different degree marks too. I would highly recommend, and I don't think you guys would do this, but don't multiply these out and give me a decimal, because you're going to have to round. And if you keep using rounded values, you're going to get further away from the answer. Let the calculator do all the heavy lifting. So leave it like this. If I want to get c by itself, I'm going to divide by sine of 38 to both sides. So little c would be 39 times sine of 32 degrees divided by sine of 38 degrees. Okay? In this place, we're going to round to the tenths place. So if you plug that all in your calculator, you get 33.6 centimeters. Okay? And you do want to be careful typing those in. It's very easy to make a mistake there. C is solved. The only thing I got left is B, right? Now, I would recommend not to use this to find B, because again, this is a rounded value, and if you got this incorrect, then you know B is going to be incorrect automatically. But here's what I do know. This is what the problem gave me to begin with. So I know that's good. I'm going to use it again. So I'm going to use sine of A over little a to find little b. Okay? So plugging my values in, I have sine of 38 degrees over 39 equals sine of 110 degrees over b. By the way, because we're doing this in our notebook, I'm writing out what the equation is and plugging values in. Do you have to do that yourself? You don't need to. You can just jump right to this. That's no big deal. Cross multiply, we get b, sine of 38 degrees, equals 39 times sine of 110 degrees. And just like the prior one, we're going to divide both sides. In this case, we're going to divide by sine of 38 to get b by itself. Again, I'm not going to plug any of these numbers in. I'm going to wait to the very end to help with accuracy. So we get 59.5 centimeters. There we go. That's law of sines. Any questions on that? So far, so good. All right. So to continue, I got some application problems I want to try out with you. All right. So let's do that next. We have a trolley car that carries passengers from ground level up to a mountain chateau. How long is the trolley cable? And the second question, how tall is the mountain? Okay. So two things to consider here. So here's the picture that I'm going to provide you. Try and draw this a little bit. Okay, so there it is. There's the picture. There's that little car going right up here. And we want to find the length of the cable. So here's what I'm going to do. This is the length of the cable. This is genius. How about C for cable? There we go. And the second part is we want to know how tall this mountain is. Okay, so that's part 2 of it. First, let's focus on the cable part. Okay. Now, looking at this, I don't have enough information to use law of sine here. Okay, so what do I mean by that? So look at theta. So theta would get paired up with this, right? And then 23 gets paired up with this, but I don't know what that is. That's 2 unknowns. That's not good. I don't know this guy, but I know it gets paired with 2,000. Again, I got 2 unknowns in that equation, not good. So we've got to find some measurements first before we use law of sines, okay? Now this measurement, theta, I could find that rather quickly because they are on a line, right? They're linear. So I can subtract 67 from 180, okay? And we get 113 degrees. So that's nice. I'm gonna need that angle because it has to get paired up with the variable that I need to solve for. Now I have 2 of the angles here. So find the third angle, I'll subtract everything from 180. Okay? So by doing that, we get this to be 44 degrees. Now I have enough information. Okay? So let's do this. I'm going to pair these up together because it has the unknown. Okay? And then I'll pair these guys up together because I have an angle with a side length that I do know. I don't want to use 23 because, again, I don't know what this is. That's unknown. Not going to help me out. Okay. So now, let's apply the law of sines. Now that we have most of our information in there, we can start using it. So we're going to have sine of 113 degrees, goes with that cable car length. And then that's going to equal sine of 44 degrees over the length that goes with it, which is 2,000 meters. So I'm going to pause for a moment. Any questions on that? Are we okay with how we went about it? So when you do these problems yourself, just be careful. Don't jump right into the formulas. I mean, you'll see when you do that you don't have enough info. All right, cross multiply. So we get C, sine of 44 degrees equals 2,000, sine of 113 degrees. We'll divide. Again, I'm going to wait to the very end to plug all this stuff in. And I did put, and it didn't really say where to round. We'll do the nearest meter, is how we'll run this one. So we're going to get 2,650 meters. So there's the length of the cable car. Okay. Any questions on that so far? Pretty good. Now the second part of the question is, how tall is it? Okay, let's figure that out. So that's going to be, well, that's 67. It's going to be a little bit in the way. Let me rewrite it. That's this guy. Okay, I got to figure out what h is. And to do that, I'm going to focus on the larger triangle. Okay, let me draw this separately just for right now. So this is 23 degrees. We know what this is. We just figured it out. There's h, and there's the 90 degree angle. I guess I forgot to put the 90 there. There we go. Okay. Now for that problem, this part of it, I don't have to use law of sines, do I? I could just use normal trig to solve for that side length. Let's do it. So this is my angle. That's opposite. That's hypotenuse. Ironically, it's sine we're using, but again, we don't have to set this up. Okay, is there a world where you could do this? Yeah, but it's a little overkill. I don't think you have to. So we'll do sine of 23 degrees equals h over 2,650. Again, we'll do some multiplying here. So 2,650 times sine of 23 degrees equals h. Plug in the calculator. And the height, we'll do the nearest meter again, was 1,035 meters then for that guy. Okay? Unfortunately, which kind of sucks, but I always warn people, don't use other values to find something else. I didn't really have a choice here, right? I didn't have any information about this length. I mean, could you figure out what this length is and incorporate it there? Yeah, but you're still using another value to figure things out. So, unfortunately, it's just kind of the way it is. If you really wanted to, what you could have done, since C is this, I mean, you could plug this in for here and multiply sine of 23 to it. I mean, there you go. That helps with accuracy. But I will tell you, though, that it'll be fine. Doing this is not going to be too much of a difference. All right. Any questions on that application problem? Guys are awesome. All right. I have one more to try out, and then we're going to do the compute the area of a triangle to wrap things up. So let's talk gazebo. So we have a bridge, and it's to be built across a small lake from a gazebo. To the dock. So we have a little boating dock. The bearing from the gazebo to the dock is south 31 degrees west. From a tree, which I'll put the measurement here. So from the tree, from the gazebo, is 110 meters. And then I have some bearings from these guys. So the bearings to the gazebo and the dock are south 68 degrees east and south 30 degrees east, respectively. Our task is to find the distance from the gazebo to the dock. Okay. And by the way, this does come with a picture, okay? Unfortunately, there's not, I mean, is there enough information? Well, you know it has to be a triangle, so you could create a triangle with those measurements there, but I will give you a picture. And to do that, there we go. That's a nice, decent lake, right? And trees over here. The gazebo's over here. I'll just call it point B, but I'll put gazebo next to it. And then down here is the dock. There we go. Now we're going to connect those 3 points to make my triangle. Okay, just like that. Now you want to build a bridge from the gazebo to the dock. So this is the unknown I want to try and figure out. So I'm going to put Y there. You can put any variable you want. Now, they did give me some angles, okay? So let's draw those in. So from the gazebo to the dock, you're going, what was it? South 31 degrees west. So this would be 31 degrees. Again, if I were to create my north, south, east, west lines, that's where I'm heading. And then, over by the tree, I have 2 measurements. So from the tree to the dock, we're going 30 degrees, and that's what, southeast. And then, respectively, to the gazebo was 68 degrees, southeast. Okay? So there's the picture. A lot going on in that picture. Here's what I would recommend. Even though it's such a lovely picture, we're going to draw another one. Okay? And the reason why I'm saying we're going to draw another one is just because this has like it has the lake in the background, it has other things happening. So I'm going to redraw this picture and find measurements that way. Okay? Now the reason why I gave you a problem like this is because this was shown on one of your final exam review questions. So I want to give you like a good example so you know what to do. So let me go ahead. I'm going to redraw the triangle over here. There we go. I'll put Y there because I want to figure out what that is. I think there's one thing I forgot to label. It's this guy. So from here to here, I forgot to label that. It was 110 meters. There we go. So we'll put 110 here. Okay. Now, I'm going to go ahead and put those angle degrees here. So I'm going to put all this to the ground. This would be 31 degrees. This is point B. There's my tree, here's my dock. Here to here was 30 degrees. And then from here to here was 68 degrees. Okay? So a good strategy, even though, again, they drew a picture for you, well, I drew the picture, it's good just to kind of remove all the background noise and just look at what the triangle is and what's the angles. And again, there's a lot going on here. So here's what I'm thinking, okay? I know I want to use law of sines, and I want to solve for this guy, right? Okay, so this guy has to go with this angle, which I got to figure out what that is. And then I got to pair it up with another 2 that has measurements. So I could pair the 110 up with this angle, but I don't know what that angle is. But I can find it. Okay, and here's how I'm going to do it. I'm going to go ahead and just put a nice little horizontal line here. And notice that I'm creating 2 right triangles with some of these measurements. And let's, I don't know, we'll call this beta, alpha, and phi. So what I'm going to do is figure out what these measurements are to find beta. And once I have beta, I can pair these up. I can pair these up and solve for my y value, my missing term. Okay? So let me just go ahead and put right angle so we can see it. So let's solve for those measurements. Okay. So looking at this triangle, we know this part's 30, that's 90, so then this must be 60. Okay. Over here, this is 31, that's 90, so a little subtraction. Okay, so this one would be 59 degrees. Now to find beta, we know they all out to 180 because they're on a line. So do a little bit of subtraction. And here we get beta to be 61 degrees. Now that's good. So now I can pair these guys up in my law of sines formula. Okay, on the other side, I want to pair these up because, again, that's where my missing term is. To find just this angle, because 68 is from this north-south line to where this is. So if I subtract these 2, this part's just 38 degrees. So now I have an angle, and I can pair it up with this side with law of sines, and I think I have all the information I need. So let's see what this looks like. Now that we have our measurements, I could do sine of 61 degrees over the 110. So again, we're pairing them up. On the other side, we'll pair these guys up. So it'll be sine of 38 degrees over y. Okay? So before I finish the problem, any questions? So just to, again, this picture's given to you, okay? I'm just redrawing it, finding some measurements, figuring out what I need specifically to create this guy. Now, we multiply together. So we got sine of 61 degrees times y equals 110 times sine of 38 degrees. And then we'll divide to finish. And we get, nearest meter, I got 77 for that guy. All right. Any questions? So far, so good? Okay. Last thing we're going to talk about is areas. All right, so I'm going to show you how to find area with sine, and I'll do one example to kind of close things out for part 1. Okay? So let's try to compute the area. Get rid of this. Let's compute the area of a triangle. I'm going to put here with a side, an angle, and a side. Okay? So here's the deal. We know how to find area of a triangle. That's no big deal. Okay? How do you find area of a triangle when it's oblique? Right? Well, how do we do that? We're going to do the same thing we did to find law of sines. Same process, okay? So let me go ahead and draw that triangle from the beginning. So here we go. Here's A, this is C, this is B, little a, little c, and little b, okay? I'm gonna draw an altitude again. Just like that. And the reason why I'm drawing an altitude is it's allowing me to use trig normally.
So let's take a look. So if I just take, let's say, sine of angle A, that's going to equal h over b. Okay, opposite hypotenuse. And if I solve for h, I get b times sine of A. Now why am I solving for h? Well, if you remember area of a triangle, don't you take half your base times your height? Remember that from before? So there's a reason why I'm solving for h here. So area is equal to half base multiplied by height. Okay? Well, the good news is we know what the height is. It's this guy. Okay? The height itself, oh, we know what that is. So let's plug those values in. I'm sorry, I said height twice. We know what the base is, I meant to say. Base is C. So my area is half. So over here would just be B sine of A times our base, which is C. I'm going to clean that up a little bit. So A is equal to a half BC sine of A. And there we go. So now we can use trigonometry to find area of a triangle. Whether it's a right angle in there, like a right triangle, or not a right triangle, I can now solve it by using this guy. Which is great. It does help us out. By the way, that's not the only way to write it. Could I draw an altitude from from A to this and do the same process? Yeah. And I could draw an altitude from B to here and go through it. So there's other forms. So what I'm going to do, I'm going to put them all three here. So area of a triangle, these are all three forms you can use, okay? So we have what I just did. I don't need a box. I'm just going to list them. There we go. Okay, so those are all three, well, that's a weird B. These are all the three forms that you can use to find the area of any triangle. Now let me make it very simple to interpret. Because again, there's a lot of variables there, and I don't want you to get bogged down with that. So if I look at the original picture, let me just erase this image. Okay, if I just get rid of that. Look at the information we're using. We're using B, which is this guy. We're using C, and we're using the angle between them, SAS, right? Okay. So again, do you have to memorize, each formula and what you're using? No, just think of it this way. To find the area, you need the angle measurement and the side that's left and right of it. Plug those in, multiply, and take half. That's what the formulas are doing. Okay? That's all you have to worry about. So let's try one final example. We're going to find the area of a triangle. Notice I don't have all the information there, but that's fine. I don't need all the information. I actually have enough there to use it. And looking at the whiteboard over there, you can see that all I need is the angle and the two side lengths that are left and right of it. That's it. That's all I need, okay? So again, it's not so much like I gotta figure out, which form am I gonna use? No, you don't have to do that. So here we go. Area is half, okay? So my B and C values, my two sides go first, so it'd be 12 times 25, and then the angle associated with them. That's it. That's all you have to worry about. That's pretty cool, because in the past, you'd have to draw an altitude, find some measurements, find your height, and then go ahead and plug it in. With trig, we can do that without knowing that. So if you plug everything in, you get 100.37, and it would be square feet.
And that, my friends, is just law of sines, but part one. Okay? Again, we'll cover the other stuff later, because there are cases where I can't use law of sines. In fact, there could be more than one triangle with those measurements, and we'll go through those cases on Monday. Any final questions? You guys are awesome.